Okay, let me open the slide. I think you all should see, yeah? That's fine. Okay, so you just need pen and paper, please, and we'll start. Can I borrow a pen for a second there? Thank you. I'll just check who's here. Okay, so I've got Abdallah or not? No Abdallah? Okay. David? No David. No. Yo? No, I only have the Chinese names or the Korean names or the English names. Could be you? Y-E-O?
Yes.
And your English name is? Oh, that's not. I should try my best. Now, I don't know who this is. This could be Bruce, maybe. I don't know. X-I-Q-I-A-N.
X-I-Q.
X-I-Q-I-A-N. Last name Yang.
No.
No Yangs? Okay.
No, Jerry.
That's Jerry.
Yeah.
Okay. No, where is he? Day one. Okay. Then, what's your Chinese name then? Are you Zhao?
Yes.
Yes, sir. Okay, yeah. And then, Sun Kanjin. Thank you. Monica.
Yeah.
Thank you. Lee. Yeah. Lee. Oh yeah. Family name Lee. So that's you. And then Ang. First name Lee Win.
Yeah.
That's you. Okay. And then last name Chu. That's you. And then Khalid. Not here, obviously. Then. Okay. All right. So we'll start. You can write this down. So we're going to start off with units and dimensions. Can you write that down? Yeah. All right. So it's typically the start of any physics course is the different types of units. Now, is this the person that was left in the canteen? Oh, the miners! Oh, yeah. Are there more?
No.
Just you. You're the only miner. What's your name?
Jerry.
Jerry. That was left in the canteen. Are you, Yang? Yes. Okay. So, you don't need to write everything down, just the key points. And you'll learn what are the key points the more lessons we have. So you don't need to write this down. You can if you want, but this slide I'm just trying to explain the basic idea. So a unit is a reference system used to measure a physical quantity. So what I mean by that is a unit's just the way we measure something. For example, we have three basic measurements we would like to make: length, mass, and time. And these are called the fundamental dimensions. So that's probably a word you want to write down, fundamental dimension, the three basic dimensions. In fact, with these three basic dimensions, you can make other dimensions. For example, the meter is what, area is going to come up, The meter is used for measuring length. And other dimensions you can make, for example, area is length squared. So just to be clear with the English, we use meter is the unit. for measuring length. The dimension is length. So the difference between unit and dimension, unit is what you use to measure it, like for example meter. Dimension is the thing you want to measure, in this case length, or length squared. They're nearly the same thing. The size, or how much of the unit you have, is called the magnitude. So this is another key word, is magnitude. That just means how big. So what is the magnitude means what is the size, how big. So the words in red are the sort of key words here. Now if that's, I know it's your first lesson, if that's too fast or if there's too much English there, like I said, you can watch this again later when I upload it onto YouTube. Okay. So moving on then. For all of you, you use the International Systems of Units. Unless somebody here is from America. Any Americans? No. So you all use International System of Units, the SI unit, or also called the metric system. Everybody uses this. It's the world's most widely used system. The only place they don't use this is America. You've got 7 basic units. So the first one we all know is the meter. That's the first of the 7 basic units. And the meter is used to measure length. Okay, so we're going to write these 7 down. So these are the 7 basic units. The first one is meter. I would hope you all know this one, otherwise we have a problem, a big problem. Okay, anybody know any other units? Meter is one. Ah, good, but no, it's not a basic unit.
Kelvin.
Yeah. Kelvin is a basic unit, yeah. Anything else?
Second.
Yes, kilogram and second, yes. So we all know some of these. So the next one is the kilogram. What does the kilogram measure?
Wait.
No, mass. Good. It measures mass. Okay, somebody said second, and that's obvious. What does the second measure? Time. Okay, what else do we have? You said Kelvin, didn't you? Yeah, we can use Kelvin. Just before that now, does anyone know this one if you've studied electricity before? It's for current, yeah. We will do this later. The ampere, is measures current. Okay, good. Next is the Kelvin. And that measures temperature then, yeah. Although there is another unit we can use which is okay as well. What's that? Yeah, degree what? Celsius, yeah. Please make sure you're writing down the symbols LMTI, and this represents temperature. What letter is that? Can anyone see? Does anyone know this one? Anyone can see? What letter is this? Theta, yeah. From which language? Greek, yeah, not English. Okay, next one now. Do we know any more? So far we have 5 basic units. There are 2 more. No. Now, coulomb actually is related to this one, so it's not a basic one. The next one is the mole. Comes from chemistry, yeah. What is it measuring? Mole is measuring mole?
The particles or molecules, I don't know.
Yeah, well, you're making it more difficult. Simply, what is it measuring?
Content.
Now, we're getting closer. Not quite. You're all making it much more difficult. content has been the closest, but not what.
Concentration.
Oh no, you're moving away. No.
Number of particles.
There we go. Doesn't actually have to be particles, okay? The mole measures how much you have, the amount. So it's amount of substance. So just how many things you have. Okay, the last one. 1,000,000 points for anybody who knows it. What's the last basic unit? No. Now Newton is a unit, but not a basic unit. Which? No? No. No, nobody wants 1,000,000 points? Okay. Huh? No. The last one maybe is a unit you've never heard before, called the candela. You've heard this one? Yeah. What would you say it would measure exactly? That's it. How bright, the intensity. So the candela measures intensity. In other words, how bright something is. This is the only unit we don't use on this course. We'll use all the other 6 units, not the last unit. Now, you said Newton earlier, or Coulomb, or so on. All these extra units, like Newton or Coulomb, you can make them by using these units. So this is what I mean by the basic units. All other units can be made using these units only. Alright. Let's continue. So, you all know this. You can only compare two things that have the same dimension. So for example, it is right to say that 2 kilograms equals 1 kilogram plus 1 kilogram. Obviously that's right. You can't say something like 2 kilograms equals 2 meters. That's quite wrong. Although the 2 is the same. This is measuring mass and this is measuring length. So they need to be the same dimension. You can compare or make equal, that's fine. If they have the same dimension, you can add, subtract, multiply, or divide. So if they have the same, you can add, you can subtract. If it's different, you can't do this. Impossible. And what about if it's different? Is there anything you can do with units that are different? So here I said if they're the same, you can add, subtract, multiply, or divide. But if they're different, is there anything you can do with them, or nothing? No, there is something you can do. Anyone?
Find a common part.
No. You'll be disappointed when you see it. No. If they're different, you can still multiply or divide them. For example, 1 meter divided by 1 second is 1 meter per second. So it's okay to multiply and divide different dimensions. So if they are different dimensions, you cannot add or subtract. But if they're different, you can multiply or divide. This is okay. So not everybody got that perfect, so you should write something down, because there's something here you didn't know. Or maybe you did know but forgot. So you don't need to write all of this down, just write something down, something that you learned that you didn't know. So just to recap, if it's the same, you can make them equal, you can compare, you can add, you can subtract, you can multiply, you can divide. You can do anything. If they're different, the only thing you can do is multiply or divide. If they're different. Yeah. Okay. let's have a look at some examples. We'll do these together. Which are valid and which are invalid? In other words, which are right and which are wrong. So together, the first one, is this allowed or not allowed? It's allowed, it's okay. Yeah. Is it right or wrong to say 5 meters is bigger than 2 meters? That's right. And can we say 2 hours is bigger than 1 kilogram? No. X is equal to 3 kilograms over 2 meters cubed? Yes, this is okay. 5 meters plus 2 kilograms? No. And lastly, 5 meters times 2 kilograms? That's okay. Alright, so you get the basic idea. Good, okay. Right, now we'll get a little bit harder. So I want to know what are the dimensions of each of the following. And I tell you that X has dimension of length and M has dimension of mass. That is, the dimension of X is L and the dimension of M is big M. So X is a length and M is a mass. So we'll do these ones together. So the first one, W equals X plus Y plus Z. So the only thing I'm telling you is the dimension of X is a length and the dimension of M is a mass. What unit could we use to measure this? What unit measures length? Meters, and this one? Kilogram, yeah. Okay. So A, W equals X plus Y plus Z, and what did I want? I want the dimension. Okay, so what's the dimension of W? Y. Is this correct? Yeah, we know that this has a dimension of L, length, yeah. If we add, we can only add if all of them are L. And if all of these are L, they add together to make an L. So the first one is obviously an L then. Okay. So let's have a look at the second one. And we can use the answers from the last part. So A equals XY. Okay, this one's a little easier. What's the dimension of A? L. No. Yes. L squared. Because it's an L by an L. L squared. Like, for example, meter squared. Yeah, okay. C. Oh, that should be a big V. V equals XYZ. Yeah, that one's L cubed. Okay, and then lastly, D rho equals M over V. Okay, so what's the density, or what's the dimension of rho? That's the unit. Yeah, dimension. You said kg. Yeah. Dimension. Mass, yeah. Yeah. And from the previous part we have the L cubed then. So these are the dimensions here. Okay, can you write these down? So this is like our first question, first example. Okay, basic stuff, but it is the first class. Got that? Yeah?
What is Y and Z?
There are already
Good. What do you mean by what is?
Because we only know X.
True, we do only know X. But because we know X, we also know Y and Z. Y and Z must be the same as X because we're adding. So for example, if I said 1 meter plus Y plus Z, these must be in meters because of the adding. Yeah? It was my trick. Okay, continue? Yeah. Is that yes or no? Continue, yes? Okay. Right, so this one is just a continuation. Now I want to know the units. So we'll just put the units beside. I'll put in red. So what's the unit for the first one? It's obviously meter. For the second one? Meter squared. The third one? Meters cubed. And the last one? Kilogram per meter cubed. Okay, so just add those in too, please. By the way, what do they use in America instead of meters?
Inch.
No, he's close. Not quite. Well, you could use inch, but what's bigger than an inch? Feet. And what do they use instead of kilogram? Pounds. You ever hear of this? Yeah? What letter is pounds? What is it, yeah? Yeah. That's what they use in America. Why they don't use this, I don't know.
Well, I have a question.
Yeah.
I studied in America, but I graduated there.
Oh, good. You had a good teacher then. Yeah.
Oh, okay.
A lot of science teachers maybe use this, but for example, a place like you know NASA. Do you know NASA? Yeah. They still use pounds and feet for their work, their calculation. So in school, it's good that they use this, but sadly, in real life, in America, they still use this. Sadly. Okay. Right, so the last question I was kind of hinting at a new idea. We call it density, and it's measure of mass per volume. And the formula is mass divided by volume. And this is something you probably already know. And what does this tell us about our material? What is density? Like, what does it mean to have a big density? What does it mean to have a small density? Hard to explain. What's a simple way of saying?
Concentration.
It's like a concentration. It's like how much you have in a space. And we already seen what the unit, the dimension is. What's the dimension of this density here? We had it in the last question. It's mass per L cubed, length cubed, yeah. And so the unit is kilograms per meter cubed. Now, what I wanted to show you was some people use this, and that's okay. But from now on, I'm only going to write it like this. I hope you've seen it written this way before. This is the way that is normal nowadays. We and I will not use the forward slash anymore. It's not normal usage. Instead, we'll use this minus power. So ml minus 3 means m per l cubed. Okay. So we don't write this. Instead, we will write this. Okay. Yeah. By the way, what letter is this? Rho. Which language? Greek again. Okay. So if you can write this definition down, please. Our first definition, I suppose. Okay. Have you got this definition? Yeah? Yeah, okay. Right, let's have a look at some examples now of change in units. So what is the density of water? If 1 litre of water has a mass of 1 kilogram and 1,000 litres make 1 metre cubed. So I want to know the density of water here. Okay, so let's have a look here. Density is mass over volume. And let's say, for example, we have 1,000 litres. Well, in the question I said 1 litre has a mass of 1 kilogram, so 1,000 litres would be 1,000 kilograms. And what would be the volume? Well, I also tell you that 1,000 litres is 1 metre cubed. Yeah, so this will be 1,000 kilograms per metre cubed. That's the answer here. So the density of water is quite large. Water is pretty dense. Yeah. Now, that's a simple example. We'll start making them more difficult. So if you can just write this example down. It's a simple example. What is the density of water? Okay. Got that? Yeah. Now, we can use something called prefixes to make units bigger or smaller. You already know one prefix, kilogram. So we already have one from just basic life. These are the ones we use for this physics course. Let's start just to say, an example is a kilogram is 1,000 grams. So kilo means 1,000. Like kilometre is 1,000 meters. And centi, 100 centimeters is 1 meter. So we need to look at what are the common ones we use. We'll start with the biggest, giga. Giga is G, and that's 10 power 9. Which I think is a billion. So the giga is a big value, big prefix. Does anyone know what's next? Smaller than giga? Mega? What letter? M first, yeah. How many zeros? 6, yeah. It's 1,000,000. Okay. So thinking about your computer then, what's next after mega if we're getting smaller? Kilo, which is a K, which is 10 to the 3, which is 1,000. Right, now, next. Yeah, centi. What letter is centi? C, just C, yeah, yeah. How big is it?
-2.
Yeah, 10 negative 2, 0.01 centi. Next. Milli, very good. What letter? 10 minus 3, 0.001. Next. Uh-oh, running out. What's next? Micro, what letter? What letter? Not M? Did you say it? What letter? Close.
Like U.
Yeah, what's it called? Mu. 10 power minus 6. And the last one we'll do, after micro. Nano, letter.
And
Very good. How many zeros? 10 to the minus 9. Quite a small unit. Good, good. Okay. You knew all of these, which is good. There are others, of course. These are the common ones we'll use. There are many more. In other words, these are the ones you need for the exam. Yeah. Okay, continue. Yeah. Now, this is important because some of you learned how to change units in high school. In fact, maybe all of you learned how to change units in high school. And you probably learned how to do it a way I don't like. Because I don't think it's a good way, I'm guessing. So I'm going to show you the way I like you to change units. It's the way that will least likely have you make a mistake. The way that you learn how to do it in high school, it causes a lot of mistakes. So the way I'm going to show you how to do it will have less mistakes. So first question is to change 50 kilometers per hour into meters per second. Okay, 50 kilometers per hour into meters per second. And then we'll look at the other part in a moment. Okay, so 50 kilometers per hour. I want it into meters per second. This is how I do it, and this is how you need to do it. Okay, so first I'll just make that a bit clearer. Km over h. And the way I like to do these is when I see a prefix like k, I give it its number value. So in this case, k represents 1,000. I still have m over hr. And also, hr is an hour, 1 hour. How many seconds is that? 3,600. Yeah. And that is in seconds. So I've changed it now into meters per second. So it will be 50,000 over 3,600 meters per second. We'll calculate that now. There are other ways to do it. I can think of 2 other ways to do it. I'll just scroll just for a moment to the left. There is this other way of doing it where you have like 50 kilometers per hour, and then you break this up into something like this, and then you change this into I don't like it. And there is another way to do it as well. I don't really want to show you the wrong ways of doing it. Okay, it's not wrong, it's just this way is clearer, neater. You treat the prefixes like they're numbers, which they are. Okay? Let's just simplify this. 0 cancel 0, 0 cancel 0. So that's 500 over 36. Does anyone have a calculator? We can just get that 500 over 36. Yeah?
13.89.
13.89 meters per second. Okay, can I do the next part? Yep. Next part. Now we want 50 kilometers per hour, and we want to change this into, oops, it's stuck. Well, I know the next part. It was miles per hour. And I tell you, a mile is about 1.61 kilometers. Okay, so how to change this into miles per hour. And I tell you that 1 mile is 1.61 kilometers. Let me write that clearer. Okay, so does anyone have any ideas now? This is a bit more interesting of an example because it's not clear what to change. But we still do what I said to do first. You could change the K into 1,000, but I don't really need to do that here because I kind of want to keep the km. The problem is I need 1.61 km to make a mile. So the trick here is to divide by 1.61 and to multiply by 1.61. Is this still 50? It's still 50. But now I have something useful. I have 1.61 km. And what did I say 1.61 km is? I said it's a mile. So now this becomes 50 over 1.61 miles over hours. Or in other words, 50 over 1.61 miles per hour. Let's calculate that. Mm, 31.06 we'll say. Miles per hour. And this is a good trick that I like. You can do this because this is still 50, but you've made something you want. You want this because this is a mile and you want a mile. I think we might do another example as well. Continue? Yeah? Okay. Here's a better example. And this is a very, very good example of how you can learn how to do it badly in high school. Change 50 centimeters into meters squared. So 50 centimeters squared, and I want to know how many meters squared is that. So this is what I mean by a bad high school example, because some of you might be thinking, oh well, there's 100 centimeters in a meter, so maybe I should multiply by 100, or divide by 100, or do something with 100, but it's not this. Let's see how I would like it done. Now, 50 centimeters squared, that's actually more accurately written like this. All of the centimeter is squared. Now this can be a little bit confusing because in maths, if I said this, I definitely do not mean this in maths. Definitely not. In physics, I do, because the prefix is like it's on the meter. They're stuck together as one. So it does actually mean this. Okay. How big is a C? 0.01. Yeah? Okay, so this is 50, and this is 0.01 squared meter squared. So this is 50 times 0.0001 meters squared. So that's 4, isn't it? Or 1, 2, 3, 4. What's that? 0.05 meters squared. Isn't it? Sure, we have a calculator. Let's double check. Yeah. I missed the 0. Disgraceful. Disgraceful. 0.005? 1, 2, 3, 4. Yes, correct. 0.005 meters squared. Yeah. Okay. That was another example. This is important because a lot of the formulas we use in physics, it's important what unit we use. So for example, maybe we must use meters, but the question gives us centimeters, so we need to change it. Okay, continue. Now, just for a couple of minutes, you can start the worksheet. You can finish it at home. There's 4 questions here to practice what we just did, okay? You can start them. If you get stuck, I have the answers at the back, and you can see how I did it at the back as well if you get stuck. But try. You can work together if you want to as well. Just try this for 5 minutes, and then finish it at home.